All right, 7th graders. I just did the video on area of flat shapes. Sorry that some of it was a little hard to see, but I'm definitely not redoing it. So now we're going to just do the concept of perimeter. Let's hope this one comes out a little bit nicer. But perimeter is actually an easier concept than area. Perimeter is just the distance around a shape. You're literally just adding up how far you go. So, for example, we've got this rectangle, the same rectangle we had when we did area. Let's say that's 3 units wide and 2 units high. Well, for perimeter, we don't care how many little squares fit in there. Perimeter just means around the outside. Like the word perimeter in basketball means, you're guarding the perimeter, you're guarding around the outside. So how far do you walk to get all the way around the outside? Well, if you start there, you walk 3 units, right? And then 2 units, and then 3 units, and then 2 units, right? 3 and 2. So you're literally just adding them all up. 3 plus 2 is 5, plus 3 is 8, plus 2. The perimeter is 10. It's not square units, because you're not walking around in little square shapes. You're just walking 3, walking 2, walking 3, walking 2. That's it. Perimeter is about the easiest concept that there is. So, doesn't matter what shape you have. You just need to see how far it is to get around it. So there's a rectangle. If we had, let's say, a square, that would be really easy. Square. While we're at it, let's learn a new vocabulary word. Remember rhombus? A rhombus is when all the sides are the same. So a square is a rhombus, but not all rhombi are squares. This parallelogram here, assuming that all these are the same length, it's hard to draw, would be a rhombus as well, but it's not a square. Anyway, the perimeter of either one of these, just whatever this is, if this is 6 units, and if it's a square or if it's a rhombus, then that's 6, and that's 6, and that's 6, and 6 plus 6 plus 6 plus 6, the perimeter is 24 units. Inches, feet, yards, whatever you're measuring in. Same thing here. If this is 5, 5, 5, 5, well, then it's 5 plus 5 plus 5 plus 5. The perimeter of that is 20. Okay? It's a little different. When we had area, we needed to know the height. But when we have perimeter, we don't need to know the height. We need to know the length of each side. Perfect. All right. That's it. There's a few twists, though. For example, if I had a weird shape, a triangle with a rectangle underneath or something like that, who cares, right? You just need to know how far it is from there to there to there to there to there to there. That's it. I'm going to give you the length of this long line. We'll call it 10. We'll say this one here is 8. We'll say this one here is 3. By the way, this is not going to be exact, right? But don't worry about it. And we'll say this one here is 4. And so what do? You just walk. 10, 18, 21, 25. Perimeter is 25. Okay, that's it. Now, I can throw a few twists at you. For example, a circle. Remember, circles don't work like everything else. They don't walk in straight lines. Ooh, that one's pretty round. Right? So all we need is a formula that's been given to us by the mathematicians. And in this case, the perimeter for a circle has a fancy name. It's called circumference. So when you walk around a circle, it's called the circumference of the circle. You could call it the perimeter of a circle if you want also. But we'll call it the circumference. And the formula is circumference is diameter times pi. or pi times diameter, pi d or d pi. All right, well, what's the diameter? The diameter is all the way across the circle. So if this is 4, then the diameter is what? The diameter all the way across is 8 from one end to the other. So the circumference is diameter, which is 8, times pi. Circumference is 8 pi. 8 pi. It was good. Get it? It's kind of a joke. 8 pi. It was good. All right. Anyway, that's it. That's how you find the circumference or the perimeter of a circle. And then once again, we can get to the combination shapes, the weird shapes, like the one we had when we were doing area. We had one that looked kind of like this, and looked kind of like that. And let's say this was 10, and this was 6, okay? And then, well, the perimeter, again, you gotta just walk around, but pick a good starting point. Let's start right here and walk to there. How far have we walked so far? 10 and 6, and then 10 more, so that's 26 plus this, the halfway around that circle, all right? Do we walk back across? No, if we're walking around the outside of the shape, we wouldn't walk back across the middle, right? We just go around the outside. So the last thing we need to know is the circumference of this circle. Well, how do you find the circumference if you don't know the diameter? Well, you do know the diameter. If that's 6, then that's 6. So the diameter is 6. If it was an entire circle, if it was a whole circle, the circumference would be 6 pi. But it's not a whole circle. You're only walking halfway around the circle. So the circumference of the half circle, or the perimeter of the half circle, is 3 pi. Okay? And so now the total perimeter is, remember we did 26 before, 26, 10, 16, 26, plus the additional 3 pi. Again, we can leave it like that in terms of pi. Really easy. That's it. We can do anything. Now, let's say we do a sector, like we did, when we did area. So I'm going to, instead of a half circle, I'll just do a different part of a circle. Let me erase that. And let's say that there is a 60-degree angle, and it's a piece of a circle. And then let's say, I don't know, the radius of that circle is 6 units, right? So if that's 6, that's also 6 because it's a radius. Remember, it's a part of a whole imaginary circle, but it's a piece of it. All right, well, what part do we have? We have 60 3/60ths, which we can reduce, right? That's, we can reduce 0. That's 6 over 36. That's 1/6 of times 1/6, not of the area this time, but 1/6 of the circumference, because we went 1/6 of the way around. Well, if it was a whole circle, the circumference would be pi times diameter. What would the diameter be? If the radius is 6, the diameter would be 12. So the diameter is 12. So the circumference is 12 pi. But we didn't go all the way around. We didn't go 12 pi. We went 1/6 of that. Okay, and again, that's 12 pi over 6. We could reduce that, and we get 2 pi. It was the same answer we got with a different circle when we did area. But who cares, right? You get the idea. Very, very, very simple. Now, wait a minute, though. I could ask you in a variety of different ways. I could say, this is called the arc length. So the arc length is 2 pi. But if I really wanted to know the perimeter of the shape, what would it be? To walk around would be 6 plus 6 plus 2 pi. So it would be 12 plus 2 pi is the perimeter of that little shape. And once again, I like leaving things in terms of pi. Perimeter is so easy. Now here's the catch. Here's the rub. Here's the thing that I can throw at you, which I did, which you learned, and I'm going to have you guys do, is some shapes, I'm not going to give you all the sides. So how are you going to walk around if you don't know how far one of the sides is? Well, I'm going to do this with triangles. And I'm going to start off with a simple triangle, a right triangle. And this only works for right triangles. So I'm just going to say, I don't know, this is 3 units high. And this is 4 units wide. Okay, so how far did I walk? 3 and 4, that's 7 so far, right? But I don't know how long that line is. Well, remember we learned in class that there's this thing called the Pythagorean theorem, okay, that says a squared plus b squared equals c squared. And remember, a and b are called the legs, the straight legs, and c is called I'm going to write the word up here, c is called the hypotenuse, okay, which is the long side diagonally across from the 90-degree angle, okay? A and B are called legs. All right, so use the formula. It's actually really simple, right? A is 3 squared plus 4 squared equals c squared. All right, and 3 times 3 is 9. 4 times 4 is 16 equals c squared. 9 and 16 is 25 equals c squared. Now you have to do a little bit of math here, right? That's why I'm having you memorize your squares. What number squared, what number times itself is 25? You should know that, right? C equals 5. So now we know that the length of that is 5. Now we can do the perimeter, right? 3 plus 4 is 7 plus 5. The perimeter is 12. 12 inches, whatever they are, okay? Pretty easy. So we'll take a little time out here and work on some of these Pythagorean theorem, right triangle problems, right? Let me just give you another one. All right, I'm going to erase this one, and I'm going to say that, let's say, this one is 5. That's a terrible 5. 5. This one is 12. And this one, I don't know. Okay. Well, how am I going to find that? Again, the two straight legs are A and B. The hypotenuse is C. So 5 squared plus 12 squared equals C squared. 25 plus 144 equals C squared. Add that up, 169 equals C squared. And again, that's why you got to memorize your first 22 squares. Or you could guess and check. What number times itself? Well, 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. Okay? So C is 13. There's C right there. Okay? And now if you wanted to do the perimeter, 5 and 12 is 17, and 13 is perimeter's 30. Okay? All right, now, you may have noticed that both times these came out nice, right? Like 169 has a perfect square root. It's called a perfect square, right? The number 11 doesn't have a square root. There's no number times itself equals 11 or 172, or there's all kinds of numbers that aren't perfect squares. I'm not going to give that to you, but just for the heck of it, let's just kind of do one. All right, so what if I just said, like, I don't know, this is 4 and this is 7. That's got to be a right angle for this Pythagorean theorem to work. And let's say this is, we don't know. Well, 4 squared plus 7 squared equals C squared. 16 plus 49 equals C squared. 65 equals C squared. What number times itself equals 65? Well, close. 8 times 8 is 64. So we know that's about 8, but it's not exactly 8. And we're never going to get it exactly. It's going to be like 8.1 something something. It's called an irrational number. It can't be written as a ratio. But what we can say is that it is the square root of 65, whatever that is, a little bit more than 8. All right, if you had a calculator, you could figure that out. Punch it into your calculator. But again, we can leave it in what's called radical form. But I'm actually not going to give you any like that on your test. But thought you should know how to do that. Now, what if I threw a little twist at you, and I gave you one of the legs, but I gave you the hypotenuse? So let's do one like that. All right. And so let's see. I'm going to go like that, and like that, and like that. Pretend that's a right angle. Okay, and I'm going to go, this is 15 units long, and this is 12 units high. How wide is it? Well, we'll call it B, right? And it really doesn't matter which one's A and which one's B, as long as the two straight legs are A and B. 15C, we know, the hypotenuse, so just follow your formula. A squared, 12 squared, plus, I don't know B, so B squared equals 15 squared. All right. 12 squared, we know, 144. Just keep working down the line when you do equations. Your equal sign should always just kind of glide down the line. All right, 144 plus B squared equals 15 squared. You should know that because we're memorizing these, but 225. Okay, now you remember when we solved equations, right? Once upon a time there was a B. That's what we want to find out. Oops, dropped something. There was a B. It got squared, and then it got added to 144. So we want to get rid of this 144. We're going to fling it over. B squared is 225 minus 144. We simplify 225 minus 144. You could work it out off to the side. You could use a calculator. You could take my word for it. It's 81. B squared is 81. So what number times itself is 81? B equals 9. Okay, so this one here is 9. And again, if I want to do the perimeter, 12 and 9 is 21, and 15 is 36. Okay, that's pretty much it. I'm going to take a quick look at your practice problems here and see if I can help you with something. Let's see. If you had a weird shape, okay, I got a really good problem here that I'm going to do with you, okay? And it'll kind of encompass a lot of different things. It'll help us to use a bunch of different skills. So I've got one on this practice sheet where it's like a rectangle. That's 8 units, that's 12 units. That's a rectangle, it's nice and straight, even though I didn't draw it straight. There's a slanted line there, and a slanted line there, and an altitude, and even though it doesn't look like it, these two are exactly the same length. That's why I put x and x, because x equals x. So that and that are the same, even though it doesn't look like it in my picture. And this is 10, and this is 10. And so we're supposed to find, let's go back and do area too. So we're supposed to find both the area and the perimeter. All right, so the perimeter is actually crazy easy, because if this is 8 and this is 8, well, if this is 8, then this is 8. So we just walk around. 10, 18, and 12 is 30, and 8 is 38, and 10 is 48. Perimeter is 48. The area is actually hard on this one because we need to do base times height. We don't know the height of the triangle. But here we go. We're going to still use our Pythagorean theorem. If this length is 12, and if it's split into 2 even pieces, then how long is each of these 2 pieces? 6, right? And if this is an altitude that goes straight down, then that's a right angle. And so these are right triangles. Okay, and so we'll just look at one right triangle just for the moment, where one of the legs is 6, the other leg is the height, we'll call it B, and then the third leg, the hypotenuse, is 10. So 6 squared plus B squared equals 10 squared. 36 plus B squared equals 100. Remember, we're trying to get the B by itself. So we want to get rid of the 36. B squared equals, look how my equal sign just keeps going down. 100 minus 36. B squared equals 64. So B, what number times itself is 64? You guys know that. B is 8. So then we just found the height of the triangle, which is 8. Now we could actually break it into 2 separate triangles, or we could just make it one triangle. If I pull that out, right, if that's this big triangle, that's 12. And the height is now, we've figured out the height is 8. So base 12 times height 8 is, 12 times 8 is 96, right? But it's a triangle, so we got to divide by 2. So 96 divided by 2, the area of the triangle, 96 divided by 2 is 48. But remember, we also have the area of the rectangle. So the triangle is 48. The rectangle area is just base times height, 12 times 8. Remember, going back to the area video, 12 times 8 is 96. And then we just add them together because we're just seeing how many squares fit in that space. So 96 plus 48, the area of the whole shape is, area of the house is 144 square units, right? 144 little squares would fit inside that shape. Okay? And that's pretty much it. So you can do area, you can do perimeter, you can do the Pythagorean theorem. One last thing about the Pythagorean theorem. It helps to know your squares. Memorize those squares. And there's also just some what we call Pythagorean triples, which make it easier to do them. You actually don't have to do the work. Pythagorean triples are right triangles whose length of sides are all integers, or all whole numbers. And we've done a few of these already, but like there's the 3, 4, 5. Remember the first triangle we did had 3, 4, and then this one was 5. So the 3, 4, 5, it's one that people will memorize and they know. And then any multiple of 3, 4, 5, right? Like double 3, double 4, double 5, or triple 3, triple 4, triple 5, anything. You could have a 30, 40, 50, right? If one side is 30 and the other's 40, then the other's 50, okay? Because they're in that 3 to 4 to 5 ratio, if it's a right triangle. There's the 5, 12, 13, which we did. And of course, all those multiples as well, 10, 24, 26, and so on and so on. So, you don't even have to do the work. You just look at triangles and say, oh, that's a 6, 8, 10. Oh, that's a 5, 12, 13, right? There's also the 8, 15, 17, okay? 64 and 225 is 289. And then all the multiples of that. There's tons of other ones, but these are the most common ones that you'll find in problems and that you'll find on any of my tests or anything like that. Okay? That's pretty much it. And I hope you enjoyed, and we will send out these videos to you. All right.